Good afternoon all. So we are into the second lecture of the Golden Jubilee celebrations of Science and Technology in Kerala. And now today we are having Dr. Shrikanth Badole as our distinguished speaker. He will be presenting the topic, what has soil to do with climate change, a very relevant topic given the context of the global climate change. Dr. Shrikanth is a scientist B in the Department of Soil Science. And he did his master's and doctoral degree from Bidhan Chandra Krishi Vishwavidyalaya, Mohanpur, West Bengal, with meritorious scholarships for both his PG and PhD studies. He has nearly 19 journal publications and 5 book chapters to his study. And he has got extensive experience in soil carbon studies, and today we are very fortunate to have him as our distinguished speaker. Over to you, Dr. Shrikanth, for the presentation.
Good afternoon all. Today's my topic is what has soil to do with climate change. Okay. First of all, we discuss about this soil. As we know that soil is a wonderful gift of nature to God from the nature for human beings. Why it is a wonderful gift? Because all our basic needs, right from our food, shelter, and home, that can be fulfilled by the soil. So our existence is mainly depend upon the soils. Also, it has several functions that we discuss. First, most important function of soil is storing and cycling of nutrients. There are 17 essential nutrients that is required for the normal plant and growth. All are can provided by the soil. But majority of these, the primary nutrient like nitrogen, phosphorus, carbon and sulfur, these nutrients are present in soil. There are around 95 to 98% are present in organic form, which is available to the plant through soils. Most of them, only 1 or 2% that is available from the fertilizer that we have applied externally. Then it is provide a structural stability. For growing a plant, we require a stable structure, even for our withstand also. There are several now advancement of science. There are different technology like hydroponics or aeroponics, where we can also grow the crops, but that is only around 2%. We cannot exclude the soil for the production purpose. Then apart from that, it will provide a biodiversity and productivity. And it is the house for the number of biological activity and biological diversity. There is no soil without life, and there is no life without soil on the planet of Earth. Then the main, for the climate change in concern, the major function of soil is curbing global warming. How it is curbed? Because it is capture this carbon from the atmosphere in the form of soil, and it is stored in the soil organic matter in the form of soil organic carbon. Then apart from that, there are also functions. That is, it acts as a physical medium. So if we have to live, then we require the soil or earth surface. Okay. Then second function is, it is as a source of raw material for building like bricks, then clay pots and so on. And also it acts as a cultural heritage for various archaeological sites. Then come to our main topic is soil and climate change. As we all know, the soil is a major reservoir of terrestrial carbon. Among the total carbon of terrestrial carbon is around approximately 3,170 petagram, of which 2,500 which are present in the soil. And that is, if we equivalent to the atmosphere, it is 3.3 times higher. And in terms of, we compared with the biotic pools, it is 4.5 times higher. Okay, and which is around the soil pool, it is totally around 2,500 petagram, of which organic carbon is 1,550 petagram and inorganic carbon is 950 gram. Together it is contributing 2,500 petagram of carbon. And in case of Indian soil, Indian soil contains the organic carbon about 9.5 petagram of organic carbon and 4.13 petagram of inorganic carbon. Beside this, soil organic carbon. Okay, this soil organic carbon for any soil, whether it is healthy or what is about resilience, it is depending upon the amount of soil organic matter content present in the soil. Okay, to maintain the soil quality or soil health, we require the optimum amount of soil organic carbon. It is the major indicator of soil health and soil quality is soil organic carbon. Then also it impart resilience. Resilience means once we disturb the soil, when it is how it will become return back its original position after disturbance. That is only possible if we have soil contain the good amount of soil organic carbon, or we can simply say the soil organic matter. Okay, so as now we see that most of the agriculture production comes to plateau. Why? Because of our soil is having content of very less amount of carbon. We are compared to the temperate forest, temporal area. We have around in our soil hardly it is present in 0.3%. So most of it is lower, except the forest soil which contain the good amount of soil organic carbon. Then it has potential to curbing global warming, as I already explained that by capturing the carbon from atmosphere and store into the soil. Okay, and it is necessary to maintain the soil health and soil quality by maintaining soil organic matter to ensuring the food security. Then soil, it is either both, it is acts as a source or sink of carbon dioxide. As it is a major pool of soil terrestrial carbon, it contributes around 2,500 petagram of carbon, of which if we are managed properly, then it is acts as a sink. So it can absorb the carbon from the atmosphere and store it into the soil. Or if we are not managing it properly, then what? It will contribute to the atmosphere. So if any change in this stored amount of soil organic carbon, which increases, that will increase the atmospheric carbon dioxide concentration. Then there are 4 ways by which carbon is losses from the soil through the oxidation of organic matter during their decomposition by different microorganisms. It converted this raw organic matter to well decomposed organic matter. During their oxidation of organic matter, it will convert this into the carbon dioxide and it is released to the atmosphere, particularly in the aerobic condition. And in aerobic condition, it is lost in the form of ammonia, particularly in rice soils and wetlands. Then it is also lost along with the leaching percolating water. There are around 10% of carbon. It is in the form of dissolved organic carbon that can be leached down along with the percolating water into the ground, so that it will also be lost. And 4th factor is runoff. By the runoff, we also lost the soils, fertile surface soils, by which also it lost the soil organic carbon. Then there are different processes by which we protecting the soil carbon. There are mainly 3 pools. One is your labile pools. Labile pools which is present in the soil for a few period of time. And next one is the slow pool. And third one is your recalcitrant pool. So this unprotected soil carbon, which is denote your labile pool. Because for maintaining the good soil health and soil quality, we need a certain amount of organic matter will also be utilized by the microorganism, and during their assimilation, it will convert it into the carbon dioxide and it is released into the atmosphere. Then second process is physical protection. Physical protection is simply nothing but the physical encapsulation of soil organic matter into the aggregates, and by which we will protect from the microbial attack and it will reduce their emission. Then third one is the biochemical protected soil carbon or chemically protected soil carbon that is stored in the soil for a longer period of time. This is recalcitrant, as because it is the biochemically changes, it will form the organomineral complex with the organic matter and mineral surface, and by which it is stable for a longer period of time. Then if we see the trend of concentration of greenhouse gases, more major greenhouse gases is the carbon dioxide, methane and nitrous oxide in the atmosphere that are increasing trend. As per the IPCC 5th assessment report, in 2014, the first time we observed that the atmospheric carbon dioxide concentration has almost crossed the 400 ppm level. Then the methane concentration is increasing from 800 to 1800 parts per billion. Then nitrous oxide concentration also be increased from 270 to 320 billion from 1950 to the 2010. Then this soil, the major cause of carbon dioxide emissions are, first is your fossil fuel burning. It is the major contributor of the emission of greenhouse gases. And next to that is our agriculture and forestry, mainly from the land use and other management practices of the crop that are mainly responsible. And second most factor which will contribute more amount of carbon dioxide. These are the some key drivers of greenhouse gases emission from the soils. First, we discuss the humidity. Humidity is nothing but the present of amount of soil moisture, amount of soil water content or water filled with the pore spaces. If the soil water filled with the pore spaces that is less than 10%, then there will be no emission of nitrous oxide. And if it is the around 60%, and in agriculture term we call as the field capacity. In field capacity, most of there is a good amount of water as well as air, so continuous environment are present for the different microbial activity. So during that time, so most of this organic matter at a 60% water filled with the pore spaces, most of the organic matter is decomposed and it will convert this nitrogen, organic nitrogen into the nitrous oxide, and it will be emitted to the atmosphere. And it will be increasing up to the 80%, and it will drop above 80% and below 10%. Then if the soil moisture is 100%, this water filled with the pore spaces are completely filled with the water, that is 100% filled, then it is having the anaerobic condition. Particularly in lowland rights or wetland condition, the complete 100% pore spaces are filled with the water. As because of this 100% filled with the water, it creates an anaerobic condition, and in that condition, most of the emission in the form of methane. So these are the two, in case of moisture, it is the important. And then the precipitation. In initial period of precipitation, there will be increasing the emission of greenhouse gases, and it will be reduces with the later period. Okay, and it is also depending upon the soil type. If it is a light texture soil, then emission will be less, and if it is the fine texture soil, so it holds the good amount of water and aeration, therefore it has more amount of greenhouse gas emission. Then come to the next factor is temperature. So as we know that every 10 degree rise in temperature, it will increase the activity of microorganism, and as the temperature is rises, it will increase the emission of greenhouse gases. It up to this certain level, then again it will be dropped down, and also below 10 degrees centigrade, also less mineralization of organic matter, there were less emission of greenhouse gas. Then second thing is the exposure. Exposure basically based on the altitude. If we consider the topography, then first one is the top hilltop, then a hillside slope, and third one is your depression, or we call it as the toe slope. In most of the cases, there will be more emission of greenhouse gases in the toe slope or in the depression because of having the good amount of organic matter as well as the moisture that will be favorable for the decomposition, and it will help to increase the greenhouse gas. Then also the wildfires, or simply we call it as the forest fire. This forest fire also contribute to emit the greenhouse gases, but it is depend upon their temperature as well as the duration, how long it has. Then the next factor is the nutrient. In case of nutrient, CN ratio is very much important for any mineralization or decomposition. Okay. In case of CN ratio, if it is CN ratio is more than 30, then the less amount of organic matter is disintegrated, therefore less emission will be occurred. And if the CN ratio is less than 11 or less than 10%, then the easily decomposable material are present, so more amount of greenhouse gas emission will be occurred, as the most of the microorganisms are attack on that organic matter, and it will increase the greenhouse gas emission. Then next, in that, first the atmospheric deposition, particularly the atmospheric deposition of nitrogen is helpful to it also increases the greenhouse gases, but at the same time it increases the biomass and leaf litter, so the compensation of loss will be less if we compare with this. And the most important is land use management, how we can management, particularly in agricultural cropping, high intensity cropping with the conventional tillage practices, that will also be increased, that will be responsible for the increase in greenhouse gases. And in case of forest, different forest management practices like site preparation and clearing of forest, these are the most two important things which will increase the greenhouse gas emission. The next factor is the vegetation type. Vegetation, okay, vegetation it is dependent upon the type of vegetation as well as the age of that vegetation. In initial period, when the stand is young, when the forest stand is younger, a young stand, there will be more emission as compared to the aged one. And leaf area, in case of aged land, aged forest land, having a more duration forestry, which having a more leaf area, as because of the more canopy, it will reduce their shade effect will reduce the temperature, and thereby it will reduce the greenhouse gas emission, because temperature and moisture is an essential factor for the greenhouse gas emission from the land surface. And most important is the land use and land cover change. This land use and land cover change is mainly responsible for the emission of greenhouse gases among all the factors. This is the major factor by which we can contribute the greenhouse gases to the atmosphere, particularly when the forest land, peatland or grassland we converted into the agricultural crops. Then come to its management. For agricultural crops, we have to adopt some improved crop management practices by which we can reduce the greenhouse gas emission. The first most important thing is the increasing soil organic matter content. Okay, this increasing soil organic matter content is necessary for ensuring the food security as well as the storing the carbon into the soils. As most of the soils in agriculture, 80% soils are having less than 0.25% of organic matter and having potential to reduce the greenhouse gas emission by 20%. Then second crop important management practices is the improved water management practices. As if we are following the improper management practices, it increases the moisture level, and ultimately it will indirectly contribute to increase the greenhouse gas emission. Then the precision fertilizer management. This is most of the in agricultural cases, most of the emission that is comes from the nutrient management, particularly the nitrogenous fertilizers. So there are different precision technologies by which we can adopt and reduce the greenhouse emission. Precision means precisely where and when you want. Okay, by using the advanced technological tools like IoTs and different unmanned vehicles and different things, or using remote sensing technology, we will know and which area on the basis of their NDVI, which area are deficient of certain nutrient or certain problem is there. On the basis of that, if we can manage the soil, so it will be helpful to reduce the. Then the different crop establishment practices. These three establishment practices particularly comes from the conservation agriculture background. In conservation agriculture, where the main objective is the maximize cover, minimum soil disturbance, and go for the crop diversification. So by which improved tillage practices and crop establishment practices like no tillage, zero tillage we can follow, or minimum tillage. Then changing monoculture to crop diversification, so it will enhance. It will help to increase the nitrogen fixation as well as increase the organic matter into the soil and reduce the greenhouse gas emission. And third one is crop residue management. This is important particularly in case of Punjab, because of the most of the crop residue they are burned. If we go for the conservation tillage practices like mulching and others, so it will help to reduce the greenhouse gas emission. Then now is the biochar application to soil. It is also biochar is basically pyrolysis product in high temperature, which has potential to sequester the carbon as well as the having great surface area, so it can absorb the more amount of nutrient also. It can hold the more amount of nutrient as well as the carbon from the atmosphere. And the major one is the, if we go for the agroforestry, it is the best method by which we can conserve the more amount of carbon in agricultural soils. Then come to the forest management practices. The first, in case of forest management practices, the first most important is the protection of primary forest. Okay, if this primary forest is converted into secondary forest or some disturbance by the human beings, then it will reduce the 10% of their soil carbon stock. So whatever we have a primary forest, we need to protect them. Then second important management practice is the partial harvesting method, because most of the emissions comes from the disturbances occur particularly during the harvesting. So during the harvesting, we also lose the 10% of their soil initial or soil carbon stock, and in the future, in few years, we will also lose the 30% of their carbon stock because of we having less litter fall and more decomposition as the surface area is exposed to the soil temperature. And third one is the minimum soil disturbance during the site preparation. So whatever method we have to minimum soil disturbance, that can be adopted, by which we can reduce the carbon emission. The nitrogen addition, this nitrogen addition always help to increase the soil organic carbon by increase the canopy cover as well as the leaf litter fall. Then selection of species with nitrogen fixing associates like acacia and something other else, I don't remember the name. Okay, so this can also be useful. It will increase the nitrogen fixation, thereby increase the improve the nitrogen availability to the plant, and by which we can have increase the crop cover as well as crop cover canopy and increase the organic matter content in the soil. Acts as a shade effect, and it will reduce the temperature, and by which we will reduce the direct exposure of soil to the direct sun, and by which we can conserve the soil organic matter for their decomposition. Then management of stand density. It has found that instead of low density planting, high density planting is the beneficial for increasing the soil organic carbon. And always go for the afforestation, where we have a degraded land or deforested land, that will help to increase, to store the soil organic carbon. Then, and most important is reduce the deforestation and forest degradation. That will help. If we reduce the deforestation and the forest degradation, we will also take care of the soils in terms of climate change. Then one important message is soil is a very important earth resource. Save it for your first step. Thank you.